Okay, so we're going to be talking about multiplication rules of exponents. Now, first of all, if you had something like this, well, actually, first of all, let me clarify something. I'm going to first show you what multiplying is longhand, I mean the long way, which is the way you'd have to do it if you didn't use shortcuts. And then most of these lectures that we're doing on this are going to be talking about shortcuts. So, okay, but the shortcuts make it much easier and much quicker to do than if you did the long way, right? So the long way, if I were asking you, well, here's the rule, first of all. The first rule. X to the m times x to the n is equal to x to the m plus n. So when this is your base, your x is your base, your exponent is your m and your n. So if you multiply same bases times exponents, your final answer is that same base raised to the addition of the two exponents, right? You're adding them. You guys all know that at this point, right? You're pretty comfortable with that. But I'm going to just show you the long way. If I did it the long way, if I did x to the fourth times x to the sixth, actually, let me just do this slightly different way. Let me use a different color. X to the sixth. Okay, hopefully that can be seen on there. What is that? That means x to the fourth means x, the base, times itself 4 times, right? That exponent does not ever multiply times the base, ever. It just says that it's the base times itself 4 times. So that is x times x times x times x, right? And then this is times x times x times x times x times x times x. You guys agree with me? Right? That's pretty straightforward, right? Yeah. So by doing it the long way, it's really easy to see why you're adding the exponents, because this says you have 4 of them in a row being multiplied. This says you have 6 of them in a row being multiplied. Our final answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's the same base, telling you how many times you're multiplying the base times itself, right? Okay, now if we had used the shortcut, we realized that if we took 4 and 6 and we added them, we'd get 10. So we're just doing x to the 4 plus 6, which is x to the 10. Now, the reason why we do the shortcut is if I gave you this, x to the 47th times x to the 252nd, I would not want to write those all out like this, right? It would take me forever. So knowing the pattern helps me, and it helps me to create the shortcut, and it just helps me realize, oh, I've got to add that to that. So that would be x to the 299, am I right? 299, am I right? Something like that, just by adding those two exponents together. So that's really easy, right? Okay, so now there's a rule that I want to talk about. And this rule says, let's see, I can go to that. Okay, never, ever, and I'll just do one ever, but I usually do several. Never, ever multiply the base, or the exponent times the base. That's so important. Never, absolutely never. So if I had, so in order to talk about that, I'm going to now move on to the next rule, okay? This was one multiplication rule. Now our next rule is this. X to the m raised to the n power is equal to x to the m times n. Yeah. Okay? Right? Remember, parentheses always means multiply, right? Always. That's the only time you're ever going to multiply exponents, is when there's parentheses between them, right? But you're only multiplying exponents. You are never multiplying the base. Does that make sense? Ever, ever, ever. Never multiply the base. So in this scenario, you can have a variable, but you could also have a number. X could be a number instead of a variable. So for example, I'm going to erase this. Is that okay?
Yeah.
So that you can start fresh here. So if I had 2 in parentheses, well, no, I don't want to use, yeah, that's fine. 2 in parentheses raised to the 3rd power. That, what am I doing?
It only affects the 2.
Yes, but remember exponents, when you multiply them, exponents multiply times exponents. Only times exponents. They never, never multiply times the base. So what is the base?
2.
The base is 2, right? So suddenly, what is the exponent on the 2?
1.
It's a hidden 1 right there. So really, you're multiplying the 3 times that 1. Does that make sense?
So
You see
it's
what I'm
2
doing?
to the 3rd.
It's 2 to the 1 times 3, or 2 to the 3rd power. Now, if it doesn't have an exponent other than a hidden 1, then you can just take that power and put it right next to it, right? But you're never going to say that's 3 times 2. Because 2 cubed is 2 times 2 times 2, right?
Which is 12.
Which is 8.
Oh.
You agree with me? Which is what?
No, sorry.
Okay.
I said 12. I'm
12.
sorry.
Yeah, you got it. Okay, so so if I did this, 3 to the 7th power, I would immediately say 3 to the 7th, right? You with me?
Mm-hmm.
And if I said, you know, 4 to the 8th power, it would be 4 to the 8th. And I 4 times 4 times 4 times 4 times 4 times 4 times whatever, right? Now, but there's one case where you could do it wrong and get the right answer. And if you base your entire the method by you doing this, like if I had the base as a 2 and I had the exponent as a 2, right? I could say 2 times 2 is 4, and that would be the right answer, but I did it wrong. Does that make sense? Because you never multiply the base times the exponent. Does that make sense? Never, never, never. So really, in order to get the 4, you can't go the exponent 2 times the base 2. You've got to do the base 2 times the base 2 twice, right? The base 2 times itself twice. And that would give you a 4 as well. But that's the only case where you could do it wrong and get the right answer. Does it make sense? But these, it is not 8 times 4. It is not 3 times 7. It is not 3 times 2. Right? You get that? Okay? So now the next rule, well actually, let's keep going with that rule for a second. So now let's do it with variables. Variables. So if I had x to the 4th raised to the 8th power, what would I do? X to the 4th raised to the 8th is x to the 4 times 8, right? So x to the 4 times 8 is 32. Yes? Okay. So, and what if I gave you x, y, z raised to the 5th power? It is not 5xyz, right? Because that would be multiplying times the base. It's the exponents, it's multiplying times the 1. Therefore, it would be x to the 5, y to the 5, z to the 5. Does that make sense? Okay, cool. Now, then there's another rule that looks very similar to this one, which is this. X, let me think. X to, let's see, how did I write it? Well, there's different ways I could write it. I'll do it this way. X to the m times, yeah, okay, all right. X to the m times y to the n is equal, raised to the p power. I don't know. Okay? So that would be x to the m times p times y to the to the n times p, right? You with me? Okay? So I'm this p is next to the parenthesis, therefore it affects everything inside. The only thing it does though is multiply times the exponents. It never multiplies times the base. So if I had x squared y cubed and I was raising it to the 5th power, what would it be? X to the 2 times 5, which is 10, y to the 3 times 5, which is 15. Am I right? Okay, that's pretty straightforward. I think everybody gets that, right?
Mm-hmm.
Oh God, you need it right now? Oh God, we started late, didn't we? Okay.
Started a little late.
Yeah, 2 more minutes.
Okay.
Okay, thank you. All right, this is going to be a very short lecture, but I'm going to have to continue the lecture after I stop this, okay? Now, what if, though, this number was an actual real number instead of a variable, right? So let's say I had this, 2x squared to the 3rd power. I have to, the 3rd power is next to a parenthesis. It affects the 2 and the x squared. Does that make sense? Yeah. Therefore, 2 cubed, because I'm multiplying the 1 exponent on the 2 times the 3, so it's 2 cubed, x to the 2 times 3, 6. Does that make sense? And if I wanted to go further, if that's easy to figure out, I'll figure it out. If it's not, I won't. I'll just leave it like this with an exponent. But if it's easy, then I'll just say that's 8 x to the 6. Everybody clear on that? So what if I gave you,
Wait.
yeah,
How
go
did you
ahead.
get 8x? Yeah, how did you get 8x?
Because 2 cubed is 2
Ah, okay, I understand.
times 2 times 2,
I understand.
right?
Because you did it because it's simple. You can do
Yeah,
it.
I did it because it was simple, right? If it had been 4 to the 10th, forget it,
Yeah.
right? It would take me all night, all day and night to figure that out, right? So I don't want to do that. So I'm going to pause the video and then I'm going to continue. Is that okay? This was the most important thing that I wanted you to see, because that, you just have to understand, you never, ever, ever multiply an exponent times the base, ever, okay? And the times when it's most likely to happen is when the base is an actual real number, like a coefficient in front of a variable. Does that make sense? Okay.